Coach Duhon Notes video. I hope the week finds you well and that you're enjoying all of the different aspects of your life. We're going to run through this right quick, and also note that before you, hopefully everyone will see this. Our Unit 1 assessment occurs this week. It's going to be a project that will be opened up later this week. It's going to be something that you do in Desmos, and you have to submit it by Sunday evening. So be on the lookout for that. That will be your test grade for Unit 1, or 60% of your overall grade. Now, getting on with the notes. We are first going to find the point that is 3/8 the distance from A to B. So again, we break it down into an x component and a y component. For our x component, we're going from -8 to 8, so that's a total of 16. And then I'm going to do 3/8 times 16. That's 6 units. So I'm going to go -8 plus 6, because I'm moving in the positive direction to get to y, and that puts me at an x of -2. Then when I look in the y direction, I'm going from -5 to 3. That's a total of 8 units. And again, I do 3/8 of 8, which is 3. And I'm going from -5 up to 3, so I'm going to do -5 plus 3. That puts my y at also -2. So the point that is 3/8 the distance away is -2, -2. Right yonder. So again, break it down into its x component and its y component. Find the total distance, apply the fraction to that total distance, and that gives you each coordinate. Next, we're going to do something that might be a little bit confusing, but that's not on purpose. We're going to talk about the Pythagorean theorem and the distance formula. Very important. Do not use the distance formula to get fractional distance, all right? This is only for total distance. Now, if we consider a right triangle, that's where we get our Pythagorean theorem. We know that a squared plus b squared equals c squared. If I were to plot this out on the coordinate plane and call this x1, y1, and down here call it x2, y2, then I know that the length of A is just the difference in the x coordinates. So my A can be expressed as x2 minus x1, and my B can be expressed as y2 minus y1. Now, if I go back to my Pythagorean theorem and solve it for C, which means I take the square root of both sides, I get square root of a squared plus b squared equals C. Well, A is just x2 minus x1, so I can plug that in for A right here. This is A. And B is y2 minus y1, so that's my B. So a squared plus b squared equals c squared. That's how we use the Pythagorean theorem to derive the distance formula. And the distance formula is just this. You can plug in the steps 1, 2, 3, and it gives you the distance. Okay, so as always, I'm going to do the first one and ask you to pause your video until you do the second one. So in the first one, again, if I were to draw out a right triangle, I can see that this x value goes from -4 to 2, so this is 6 units. The y value goes from -4 to 3, so that's 7 units. But let's plug it into our distance formula. x2 minus x1 is 2 minus -4. And y2 minus y1 is 3 minus -4. Again, whenever I plug in a negative number into my formula, I put it in parentheses, and this minus sign belongs to the formula. So this is actually telling me this is 2 minus -4, so that is 2 plus 4, so that's 6 squared. This one is 3 minus -4, so that's 7 squared. So my D is the square root of 36 plus 49, which is the square root of 85. We always want these answers in simplest radical form, so that means we have to build our factor tree and see if we can simplify it any further. 85, I know it's divisible by 5 because it ends with a 5, and 85 divided by 5 is 17. Neither of those have any more factors, so we've gone about as far as we can go. So our final answer for this one is the square root of 85. That's it. All right, stop your video. work out the second one, and then we'll come back and show you the solution to it. All right. At this point, you should have already solved it. So let me plot out the point. -5, 6 is in here, and 8 minus 4 is in here. So here we go. We're going to plug this into the distance formula. We're going to say 8 minus -5 squared plus 6, sorry, go the other way, -4 minus 6 squared. So our D is now 8 minus -5. This is 13 squared. -4 minus 6 is -10 squared. Now, very important, when I'm putting in -10 squared, I know this means -10 times -10, two negatives being multiplied together, so it's going to give me a positive. Any number that I square gives me a positive. So I have to make sure if I plug this into my calculator that I use the parentheses. If I don't use the parentheses, it's going to give me a negative number. So this is the square root of 169 plus 100. So that is the square root of 269. I can't do anything with the 269. So that is my final answer. 269 has no factors. All right. Let me see if this shows up on my screen here at all. So what I'm trying to tell you is if I type in -10 squared, and we can barely see that, -10 squared, I type that in and hit enter, it tells me it's -100. I know that's not the case. So you have to use the parentheses if you're going to type in a square a negative number. So -10 squared is going to give me +100. You have to use the parentheses. All right. On we go to the second page. On the back, we got a couple of like what if things. So the first one is find the endpoint when the midpoint is given. So we've got A is at 1, 7. So here's our A at 1, 7. And we've got B at -1. I know my C, so if I follow this out, I know that my C is going to be somewhere down in the third quadrant. So I've got A to B, C is going to be somewhere down here. Okay, but the way that I like you to solve these is just find the change in x. Delta x means the change in x. I go from 1 to -3, so the change in x is 4. Now I'm going to do then, I'm going to go for more units to find the next point. So 1 to -3, I'm going in the negative direction. So -3 minus another 4 equals -7. So my x coordinate is going to be -7. And again, I do it in the y direction. So my delta y, I'm going from 7 to 1, that's 6. I want to go 6 more units. And again, I'm going from 7 down to 1. I'm going A to B. I want to find C. So I'm going to do 1 minus 6. That's -5. So my y is going to be at -5. So I'm saying right along in here, -7, -5. That's my C. And if I plot these guys out, they look like they're all three in a line. These two portions look congruent. So I'm happy with my work. I think it's -7, -5 is my C. All right, last little bit today. We want to find fractional distance without a graph. So again, I'm just going to look at my x. My x goes from -2 to 7. So -2 to 7 is a total of 9. I want to find the point that is 2/3 the distance. So 2/3 times 9 is 6. Now, I'm going from B to A. So I'm going from 7 to -2. So I'm going to go 2/3 the distance from 7 to -2. So 7 minus 6 gives me 1. So my x is at 1. All right, now I'm going to do the same thing for y. My y goes from -4 to 2, so that's a total of 6 units. 2/3 times 6 is 4. I'm going from B to A, so 2 down to -4. So I'm going to take 2 minus 4, gives me -2. So my y is at -2. So I'm suggesting 1, -2 is my answer. If I look just from a numerical standpoint, 1 is between -2 and 7, and it's closer to -2 than it is to 7. That's good. -2 is between -4 and 2, and it's closer to -4 than it is to 2. So that seems good. Final trick that I would recommend is actually to sketch out the points on a coordinate plane. So let's see, I start with A is -2, negative, -2, -4. So right around in there. And then B is at 7, 2. So 1, 2, 3, 4, 5, 6, 7. 1, 2. So B is at 7, 2. And the point that I'm suggesting is 1, -2, which is right there. And let's see if those all line up. Sure enough, they do. And it looks like this point is closer to, this is my B, and this is my A. And I'm going from B to A. I want to go 2/3 the distance. I've definitely gone more than half to get there. I'm happy with all that. So that is my answer. Thank you for watching and listening today. I hope you have a fantastic Monday or Tuesday. And remember to be on the lookout for